All right, we're trying to finish up this problem about our rocket, and we're trying to get it to the right volume. And I had messed up on my graphing, but I've got it straight now. I changed the x values instead of the y values. So I've got it fixed. The x values are back going from 0 to 10. Since x represents the radius, we know the radius has to be positive, so that's why the x min is, I changed to 0. And then the y max I set at 600 pi, and then the scale was at 60 pi because I know I've got a line at 558 pi. Just wanted to make sure I can see the top of my graph. And there we go. We can see that they're intersecting, so we have to figure out where that point is. So if I hit second trace, number 5 is the intersect button. Is this my first curve? Yes, it is. Is this my second curve? Yes, it is. I'm making a guess. Where are they going to intersect? Well, the intersection there is at 3. So the intersection is at 3, and then about 1753. So again, I only looked at the positive x values since x is representing the radius. We can't have a negative radius on the cone or the cylinder, so we have to only look in the positive section. So having that intersection there means to get the desired payload, we wanted the volume to be a certain amount. We wanted it to be 558 pi. The radius of the cone and the cylinder must be 3 centimeters. So again, we're just looking for where these intersecting because that's where we're going to have the solution. All right, so finishing up, a couple quick thoughts here. What does the degree of the polynomial function tell you about the zeros? It tells how many zeros there are going to be. So it tells how many zeros the function has. Polynomial equation of degree 5 has the roots 0.3, 2, 8, and 10.6, each of a multiplicity of 1. What can you conclude about the remaining root? So we know it's got 5 total roots. We know 4 of them. What do we know? Well, it has to be real. Since our complex and our imaginary all come in pairs, it's going to have to be real solution. So it must be real since imaginary and the complex solutions all come in pairs. So what are the possible ways to find all the roots? It's really best to factor if possible right away. That'll tell you what some of your roots could be. Like we did before, I remember I said if we saw an x that could be factored out, that told me there's going to be a 0 at 0. So that was an easy way. So factor if possible. And then you find the rational roots on your calculator. And then from there, if you've got more zeros you haven't found yet, divide out the rational roots. And find the complex or imaginary roots. With the quadratic formula. So hopefully these videos were helpful. I'm sorry for all of the mistakes this time. Please feel free to email me, message me if you have any questions on anything.